Hi, I'm Philip Greenspun from East Coast Aero Club. I'm one of the helicopter instructors here at Hanscom Field in Bedford, Massachusetts. Today we're going to talk about how the helicopter flies and give you the information that you need before you start handling the controls of the helicopter on your first training flight. So let's first talk about lift. So sticking your hand out of a moving car, you can generate lift just by tilting your hand up a little bit. And the amount of lift that you generate, the force that you feel pushing your hand up, is going to vary depending on the speed of the car. That's the airspeed, and the angle between your hand and the rushing air. That's the angle of attack. So the more you tilt up, the more lift you get. The faster you go, the more lift you get. And you can trade these things off in an airplane. So for example, if you're flying a little Cessna and you want to go slower, all you do is pitch the wings up a little bit more, and you can fly at the same altitude but at a slower airspeed. So how come you can't hover your Cessna? As you go slower, just keep pitching up. Well, the problem is you eventually reach what's called a stalling angle of attack, where the air, instead of flowing smoothly over the top of the wing, it begins to flow turbulently over the back of the wing, and you lose 2/3 of your lift very quickly, and the airplane will sink. That's why we developed the helicopter. If we take that same wing off the Cessna and just spin it around, like so, now we always have airspeed, even if the helicopter itself is stationary in the air. We always have rapidly flowing air over the wing. So it's literally the same wing as you'd find on a small airplane, but it's being rotated by the engine, hence the term rotary wing aircraft for the helicopter. Okay, how do we control our machine? Well, imagine that we're on the ground with the blades spinning. How do we generate more lift? The helicopter blades spin at a constant rate. Therefore, the only thing that we can change is the angle of attack. By pulling up on this collective control, we can twist the blades up and achieve a higher angle of attack, which, given that the airspeed is the same, that generates more lift and the helicopter will go up. So this collective control, if we pull up on it, it pitches the blades up, generating more lift. The helicopter will rise. If we push down on the collective, the blades twist back down and the helicopter will sink. So this is called the collective pitch control, and it's essentially your up-down control on the helicopter. So that's also tied in with the engine. As we pull collective up, we're increasing the pitch angle of the blades. Since the airspeed is the same, the blades are still spinning at 400 RPM, we generate more lift, the helicopter rises temporarily. What happens at the higher pitch angle, however, is that there's more air resistance, more power is required. If we're not tied in with the engine, the blades will just slow down and the helicopter will sink back down towards the ground. That's why the collective pitch control is tied in with the engine. As you raise and lower collective, there's a correlator inside the Robinson helicopter that's opening and closing the throttle. And on top of that, there's something called a governor, which you can actually feel it working, twisting the throttle slightly. This foam grip here is the throttle control, and you'll feel the governor. You have to keep a very light grip on this during flight so that you don't interfere with the operation of the governor and the correlator, but you'll feel this throttle twisting in flight as the machine automatically adjusts the engine power to keep the blade spinning at that 400 RPM set speed. Okay, so now you might ask yourself, well, I understand how we can hover, pull the helicopter up and down, but how do we go forward? How do we turn left and right? We want to fly forward. How do we do it? We're hanging from the rotor system, and what we really want to do is tilt the rotor system forward so that the helicopter will follow and the whole machine will pull itself forward through the air. So what we need to do is generate more lift on the back of the rotor system than on the front. How do we do that? Well, what if we could twist the blades as the rotor system spins. So this blade, for example, would twist down on the front, up on the back, down on the front, up on the back. It's going to be generating more lift on the back of the rotor system than on the front, which will cause the rotor system to tilt up, and that will pull the helicopter with it and will fly forward. We can tilt the rotor disc and therefore move the helicopter forward or left or right with the cyclic pitch control, which twists the blades cyclically as they rotate around the rotor disc. So that's in my right hand, and we make very small movements with the cyclic. It's better to think about applying a little forward pressure to the cyclic rather than actually pushing on it. So with a little bit of forward pressure on the cyclic, the rotor system will fly itself into a new tilted position and the helicopter will follow. Suppose that we want to turn left or right. Well, if we apply a little bit of leftward pressure on the cyclic pitch control, then the helicopter will develop more lift on the right side of the disc, less lift on the left side, and the helicopter will follow into a left bank. If you want to make a 360-degree turn or a 180-degree turn, you don't need to keep applying cyclic pressure. You just need to develop, say, a 10 or 15-degree bank angle with the helicopter, and then hold that angle. And if the helicopter is in a bank, it will continue to turn all by itself. So use the cyclic to get into a slight bank, hold that bank, and wait for the helicopter to turn. When you're heading in your new desired direction, then you just apply a little tiny bit of pressure to the cyclic and level the helicopter again, and it'll stop turning. There's one more control on the helicopter that we need to talk about, and that relates to engine torque. So, you've got a helicopter sitting on the ground, and you start up an engine, and now you're spinning the blades in this direction. To conserve angular momentum, the fuselage of the helicopter has a tendency to want to rotate in the opposite direction, so that the net angular momentum of this system is zero, back to what it was on the ground. Another way to look at it is that the torque of the engine pushing the blades around, the engine needs something to push against. If it doesn't have something to push against, the helicopter will just counter-rotate underneath the rotor system. So what you need is a tail rotor. This one unfortunately has lost its tail rotor. You need a tail rotor to blow air sideways in order to keep the tail pointed in the direction that the pilot wants, or to keep the tail from moving out sideways. So you put a tail rotor on the back that pushes air out this side on an American helicopter and keeps the tail from rotating opposite direction of the rotor system. How are you going to control the anti-torque system? Your left hand's running the collective pitch control, taking the helicopter up and down. Your right hand is running the cyclic pitch control, tilting the helicopter left and right, forward and back. The answer is that you use your feet. You've got a left pedal and a right pedal, and if you want to yaw the nose left or right, you just push on the left or the right pedal. That is how we fly the helicopter. So remember, very light grip on the throttle, maybe use just 2 fingers when you're learning, and slight pressures on the cyclic so that you don't get the helicopter into some crazy attitudes. Use your feet to compensate for changes in engine power, or to rotate the helicopter when you're on the ground and you want to turn around.